So EMI part 1 is the first is about Faraday's law. Electromagnetic induction starts with Faraday's law. Faraday's law. A varying flux linked with a coil. Varying flux. Can you imagine a coil is going to be moving between north and south pole? Comes to extreme position, the magnetic field will decrease and increase and decrease. Here it's decreasing, mean position increasing, then again it's extreme position decreasing. So as it increases and decreases, the flux keeps on changing. If you want to listen, you can come here and listen again. Come closer and listen. So then, because I am recording. So then first point is a varying flux linked with a coil produces induced EMF in the coil. Induced EMF in the coil. Second point, the EMF is directly proportional to rate of change of flux, which shows that if fast oscillated faster, the flux change will be more and EMF induced will also be more. So d phi by dt, where E is equal to minus n into d phi by dt. Don't explain anything about the minus sign, where capital N turns for the number of turns, and thus the EMF is directly proportional to d phi by rate of change of flux, Second point. Third point is if flux is a constant, EMF induced will be 0. Obviously differentiation of constant only is 0, so that makes sense, correct? So this is Faraday's law. Second is Lenz's rule. Lenz's rule, same as Faraday's law, but he says that there's an induced current. Here there's an induced EMF. Instead you're going to say induced current, and that induced current is going to flow in such a direction so as to oppose what has caused it. So Lenz's rule. So Lenz's rule says that the varying flux linked with a coil produces induced current in the coil. Don't say EMF, where the direction of current flows in such a way so as to oppose what has caused it. So then this, say for example, this is the outer of the magnet of the coil, this is the inner side of the coil. This is outside. Okay, yeah, the north pole is moved towards. North pole means the flux is going to increase in this direction. When you're taking it closer, it's going to increase in this direction. To counter it, you're producing a flux in the opposite direction, keeping a thumb in this direction, and the curled finger like this with the nails is inward. When you keep your head here and look at it on the right side, exactly to right of your head, you have to keep your hands, and it shows that it is anti-clockwise. That is, current is going from outside to inside. It's going from outside to inside. So it's outside to inside. When viewed from here, it is actually anti-clockwise. Okay, next is when the north pole is moved away. You have an outer of the coil here and an inner of the coil here. You moved away, the flux is going to decrease in this direction. It's kutty. Can you see? It's in this direction undoubtedly, but it's going to decrease. So you have to produce a flux in the same direction. So keeping a thumb in this direction with a curled finger with the nails pointing outward shows the current is coming from inside to outside when viewed from here. Keeping your hand on the right side, so it's from inside to outside. Inside to outside, when viewed from here, it becomes clockwise. Then is next one. You have an outer coil and an inner coil. You're going to move a south pole towards it. The flux is going to increase, yes, but in this direction. To counter it, you have to produce a flux in this direction. So the keeping a thumb in this direction, the curled finger with nails pointing outside shows when you view it from here, if you see the right side from inside to outside, which means it is actually clockwise when viewed from here. You can keep your hand and see it's clockwise. Okay, next I'm going to move the south pole away. The outer of the coil is here, the inner of the coil is here. Yeah, and you're moving away. The flux line is going to decrease in this direction, and you have to put the flux in the same direction. And so then to counter it, and keeping a thumb in this direction, with the nails pointing inward. Nails are inward. So current is flowing from outside to inside. Outside to inside, when viewed from here, keep your hand like that, like how I've given here, thumb like this. It's anti-clockwise. It is anti-clockwise. So I'm sure you understood how the directions of the current are flowing. You know, the current flows in such a way so as to oppose what has caused it. So as to oppose. So therefore this behaves like a north pole. So that it tends to repel it. The magnetic because it's coming near only, it's happening. Induced current. So the induced current flows so that it goes away. So this behaves like a south pole and tends to attract it. This behaves like a north pole. It is going closer. So it behaves like a south pole and tends to repel it. When a south pole is taken away, it behaves like a north pole and tend to attract it. So in general, if you see, anti-clockwise always corresponds to north pole. Wherever there is anti-clockwise, there is always north pole. This is a simple thing that you can always remember. Are you guys clear? So this is about this introduction to the lesson. So the first part of the next is Lenz's law conforms to conservation of energy. Lenz's rule conforms, adheres to conservation of energy. Conservation of energy, you know, you're moving a magnet which is mechanical energy, which gets converted into electricity. Induced current get produced, so therefore it is electrical energy. Then this behaves like a north pole or a south pole to repel it, so that means it is magnetic energy. And then it moves, repels it accordingly or attracts it accordingly, so it becomes a mechanical energy. A mechanical to electrical and then magnetic into mechanical says that the conservation of energy is possible. So this Lenz's rule adheres to conservation of energy. So here comes the next, so introduction is over. The real lesson starts here. You have to consider, you know, uniform magnetic field. This is like inward uniform magnetic field. This is like outward uniform magnetic field. This is like a uniform magnetic field in a plane. These are the three ways in which you can indicate magnetic field. Now I'm going to talk about an outward magnetic field. Inward magnetic field. I'm going to move a rectangular coil. The magnetic field is inward, means it's a minus k's direction. The magnetic field is in the direction of minus k. I'm going to take a rectangular coil and move it with the velocity v in this direction, which is I direction, positive I direction. So then you have to consider which is L, this is L and this is X. It's a variable. Normally L into B is what you will write, but you don't write it here. You write this unchanged breadth as L, and the what is getting a variable is becoming an X. So then you know that why when you pull it out, you know that the coil would have been here, the coil would have been here. So what is constantly coming out of the magnetic field is the X part. So then you name it as X. So now go for the Faraday's law. The beginning of the lesson, E is equal to minus d phi by dt. It's only one number of turns, there is no n. E is equal to minus d by dt of b dot ds. B ds cos theta. You should know the theta is equal to 180 here. Why? Because the magnetic field is inward and the area vector is outward. It's an angle, theta is the angle between b and ds, area. So then 180 degree. So negative sign will go away, because cos 180 itself is minus 1. So it will become plus d by dt of b into Aditya ds itself is Lx. So you can you see b is a constant, L is a constant, and a dx by dt can be grouped, and dx by dt itself is v, so bill v. So EMF induced in a rod moving in a magnetic field is bill v. You can also represent it as L dot v cross b. Why are we saying bill v when it is v cross b? There's a sin theta in but sin 90 I know. In a velocity and magnetic field are perpendicular to each other. The velocity and the magnetic field are perpendicular. The velocity is along I direction. Magnetic field is along minus z or minus k. So then therefore the angle between them is 90. So it's L dot v cross b in vector form. You know, whenever they give it in vector form, you want to find the direction of the EMF, you should cross v and b. In mathematics you have vectors. You know, when you cross two vectors, you get a vector which is perpendicular to both of this. When you want a vector which is perpendicular to the vectors, you just need to cross these to get a vector which is perpendicular to both of these, correct? So then you cross v direction and b's direction, you get EMF's direction. So that's about it. The second, this is the EMF induced in a rectangular coil moving in a uniform magnetic field. Are you clear? This is bill v. Next is about a uniform magnetic field in which I'm going to rotate a rod. Okay, take a rod, allow it to rotate in a uniform magnetic field. It will cover an angle theta, and this sector is theta by 360 into pi r square according to 10th standard portion, where here r is the length of the rod. So replace it as L square, and 2 pi also you can write, 360 you can write it as 2 pi. So pi and pi get cancelled. The area, the ds vector, ds itself is theta by 2 into L square. Now write Faraday's law. E is equal to minus n into d phi by dt. n எல்லாம் எழுதாத, number of turns எல்லாம் கிடையாது. Minus d phi by dt, which is minus d by dt of b ds cos 180. ஏன் 180 னா the area vector is normal to the area. மூக்க பார்த்து வருது, magnetic field உள்ள பார்த்துருக்கு, cos 180. So minus of minus will become plus d by dt of b எதிக்கோ, dsங்கிறது இங்கே போட்டிருக்க theta by 2 into L square. Theta by 2 into L square, what are the constants? B is a constant by 2, L square constant, d theta by dt. Because when it's rotating, theta தான் மாறிண்டே இருக்கும். So d theta by dt itself is omega. So b L square omega by 2 னு வரும். But you guys know that linear velocity is L times angular velocity or R times angular velocity. ஒரு ஆளை ஸ்ட்ரெயிட்டாக ஓட சொன்னால் ஈஸியாக ஓடிடுவான், ஒரு மரத்தை சுற்றி ஓட சொன்னால் கஷ்டப்படுவான். ஸோ எது கிரேட்டர் velocity? Linear velocity is greater than angular velocity. So linear velocity is r times angular velocity. ஆனால் இதில் தான் r கிடையாது, இதில் rக்கு பதிலாக L. So omega is equal to v by L. Omega is equal to v by L. Okay, omega-க்கு பதிலாக v by L போட்டால் b L square v by 2L. L and L get cancel. You get half bill v. Bill v, half bill v. சொல்லி கொடுத்துருக்கேன்னா. So next போயிடலாம். Next என்ன derivation? A rectangular coil is getting rotated in a magnetic field, which means spin ஆ போகிறது, spin ஆகுது between north pole and south pole. இந்த different. இது வந்து generator derivation. AC generator இதே தான் எழுத போகிறோம். You know the magnetic field will go from north to south இல்லையா? இப்படி தான் போகிறது மேக்னெட்டிக் ஃபீல்ட். அது இருந்துட்டு போட்டோம். ஸோ ஏரியா வந்து மாறாது. ஒரு காயில் ரொட்டேட் ஆகும்போது ஏரியா இருந்த இடத்துலேயே தான் இருக்குது, இங்கே ஏரியா மாறல. ஆனால் என்ன மாறுது? தீட்டா இஸ் வாட் இஸ் சேஞ்சிங், விச் இஸ் ஈக்குவல் டு ஒமேகா டி. ஓகே, ஸோ தென் தேர்ஃபோர் start with Faraday's law. E is equal to minus d phi by dt, which is minus d by dt of b ds கிடையாது a into cos omega t. 180 லாம் போடக்கூடாது, ஏன்னா theta is a variable here. அதனால இது டிஃபரன்ஷியேட் பண்ணும்போது பியும் ஏவும் வந்து டிஃபரன்ஷியேஷன் ஆஃப் காஸ் ஒமேகா டி இஸ் ஒமேகா சைன் ஒமேகா டி. Thus EMF induced is bow sin omega t. Supposing this has got n number of turns, it's ban omega sin omega t, which is similar to E is equal to E naught sin omega t, where E naught itself is ban omega. So E naught itself is ban omega னும் போது கட்டாயம் அந்த நியூமரிக்கலில் ரெசிஸ்டர் கொடுத்துருப்பாங்க. அப்போது மேக்ஸிமம் கரண்ட் கேட்டால் E naught by R, which is ban omega by R. So நீ ban omegaங்கிறது voltage by R gives you the maximum current in the coil. Are you clear? So this is about an EMF induced in a rotating coil. EMF, இது வந்து EMF induced in a rotating rod. EMF induced in a rotating rod in a uniform magnetic field. இது பொறுத்த வரைக்கும் what is it? EMF induced in a rotating coil or spinning coil in a uniform magnetic field. ஸோ இதில் வந்து ரொம்ப தெளிவாக தீட்டா தான் வேரியபிள் அப்படிங்கிறது புரிஞ்சுக்கணும். பேன் ஒமேகா சைன் ஒமேகா டி. நெக்ஸ்ட் வந்து பவர் டெரிவேஷன். பவருங்கிறது எனக்கு தெரியும் வில் வி த ஹோல் ஸ்கொயர் பை ஆர். இது நீ மக்கப் பண்ணிக்கணும். அது எப்படி வந்ததுன்னா பவர் டிரைவ்னு ஒருவரை கேட்டால் பவர் இஸ் ரேட் அட் விச் ஒர்க் இஸ் டன், ஃபோர்ஸ் இன்டு டிஸ்பிளேஸ்மெண்ட் பை டைம், ஃபோர்ஸ் இன்டு டிஸ்டன்ஸ் இஸ் ஒர்க் டன், distance by time is velocity, force into velocity, force itself is BIL, bill, force of a rod in a magnetic field is always current carrying rod in a magnetic moving in a, so bill into V. I க்கு பதிலா என்ன எழுத போற? E by R, B into EMF by R into LV. EMF for rod itself is bill V, so bill V the whole square by R is the power. இப்போது ஃபோர்ஸோட ஃபார்முலா என்னன்னு கேட்டாங்கன்னா, ஒரு வெலாசிட்டியை நாக் ஆஃப் பண்ணிட்டா கிடச்சிடும். ஒரே ஒரு வெலாசிட்டியை எடுத்துட்டேன்னா பி ஸ்கொயர் எல் ஸ்கொயர் வி பை ஆர் பிகம்ஸ் த ஃபோர்ஸ். ஸோ இது வந்து தெரியணும். அதுக்கப்புறம் என்னென்னா இந்த கிராஃப், இது வந்து ஒரு தெர் இஸ் அன் அவுட்வர்ட் மேக்னெட்டிக் ஃபீல்ட், யூனிஃபார்ம் மேக்னெட்டிக் ஃபீல்ட் இன் விச் ஆக்சுவலி தெர் இஸ் அ ரெயில் மாதிரி பண்ணிக்கோ, அந்த இடத்துல ஒரு ராடை மூவ் பண்ணுறோம். ஒரு பர்பிள் கலரில் வரைகிறேன், திஸ் இஸ் த ராட் விச் இஸ் கெட்டிங் மூவ்ட் வித் வெலாசிட்டி வி. இதில் வந்து யூனிஃபார்ம் மேக்னெட்டிக் ஃபீல்ட் இஸ் எக்ஸிஸ்டிங் for a region outward, in a region x is equal to 0 to x is equal to b, அப்புறம் x is equal to 2b, அப்புறம் x is equal to b. ஒரு குழந்தை வந்து பிடிச்சி இழுத்து விளையாடுது, 0லேருந்து bக்கு, bலேருந்து 2bக்கு, 2bலேருந்து bக்கு, bலேருந்து 0க்கு. So you got to do an analysis for this. So x is, when x is lying between 0 and b, when x is lying between b and 2b, when x is lying between 2b and b, when x is lying when x is lying between b and 0. So let's calculate the flux, which is b dot ds, which is b lx, because this again is x, this again is l, as usual. This is what x keeps on changing. So b lx shows that the flux is directly proportional to x. The flux increases as x increases, the flux increases as x increases, because you're moving it to the right. Where what happens here? The flux is equal to b into ds, which will be blb. Once it comes out, once the rod comes out of the magnetic field, the area will be lb only, correct? So blb, which is a constant. Okay, here also it is, flux is equal to blb, so flux is a constant. Whereas here it's going to decrease because you're going to compress it. You ulla kondu pora. Appo area is getting decreased. So flux is going to decrease. Flux is going to decrease with blx. So flux is equal to minus blx. Flux is proportional to minus x. So flux is decreasing. So idukku vandu na graph eppadi poda poren appdi paathana, it's a graph between flux and x is equal to 0, x is equal to b, x is equal to 2b, x is equal to b back, and x is equal to 0. Inge the increasing, inge when the flux is a constant, then here it is decreasing. The flux is directly proportional to x, the flux is directly proportional to minus x. The flux itself is the blb, that x by value is blb. Next another, let's talk about EMF. EMF ங்கிறது இந்த இடத்துல இங்க பாசிட்டிவ் ஃப்ளக்ஸ் இருந்தால் EMF will become minus blb, இல்லை minus d5 by dt. அதனால ஃப்ளக்ஸ் பாசிட்டிவாக இருந்தால் EMF will be negative, ஃப்ளக்ஸ் நெகட்டிவாக இருந்தால் EMF will be positive, ஃப்ளக்ஸ் கான்ஸ்டன்ட்டாக இருந்தால் EMF is equal to 0. So that shows that I'm going to do a graph between EMF and the position b, 2b, b, 0, and x is equal to 0. EMF பொறுத்த வரைக்கும் it will be negative when the flux is positive. This is positive flux, the EMF will be negative, which is minus blb, and here it will be plus blb EMF. The EMF will be 0 because the flux is a constant at that point. When the flux is a constant, EMF will be 0. So this is the graph. Are you clear? So the y value here is plus blb, the y value here is minus blb. So the same thing you have to do for force. A force versus b, 2b, b and 0. The force sort of formula, you know, it's b square L square v by r, which can be broken down into blv by r into bl, which is EMF by r. Force is a vector, so EMF is negative, means force will also be negative, and so then therefore the force will be here. EMF is negative, force will be here, which is minus b square L square v by r, and it's positive when it is plus b square L square v by r. When the EMF is 0, the force will be 0. Can I go to next term? Next is about power. You know, power is blv the whole square by r. Even if the EMF is negative, the power is going to be positive. So you'll have plus blv the whole square by r. Here also plus blv the whole square by r. Here the force power will be 0 at these points. X is equal to 0, x is equal to b, x is equal to 2b, to b and 0. Okay. So this completes the first part of the lesson. Okay, the second part of the lesson is switch அணைக்கிறது போடுறது, switch அணைக்கிறது போடுறது. So current increase ஆகும்போது flux will increase because of this there will induce current. கரெக்டா? என்ன பண்ணும்? Force. So second part of the lesson is current அணைக்கிறது போடுறது. So flux 0 to 5 amps இருக்கிறதோட 0 to 15 amps இருந்தால் இன்னும் flux ஜாஸ்தி ஆகும். Flux is directly proportional to I. Flux is equal to L into I, where L is known as self inductance. அதை பற்றி இன்னும் பேசுகிறேன். ஓகே, அப்போ இதை எடுத்து நீ ஃபேரடேஸ் லாவில் போட்டால் E is equal to minus d5 by dtயில் ஃப்ளக்ஸுக்கு பதிலாக Li போட்டேன்னா minus d by dt of Li. So minus L into di by dt is what is EMF. Second part of the lesson. First part of the lesson you get minus n into d5 by dt. Second part of the lesson you get minus L into di by dt. இதுக்கு முன்னாடி இப்போ வந்து I'm going to teach you what is self induction. Self induction. ஓகே, வரேன். செல்ஃப் இண்டக்ஷனில் ஒரு காயில் எடுத்துக்கோ, அந்த காயிலை ஒரு பேட்ரி கனெக்ட் பண்ண. த மொமெண்ட் யூ ஸ்விட்ச் ஆன், இட் இன்க்ரீசஸ் ஃப்ரம் 0 amps to a finite amps. ஸோ கரண்ட் வந்து இப்படி ஃப்ளோ இன்க்ரீஸ் ஆகுது. It's increasing in this direction. To counter it, there will be an induced current which flows in the opposite direction. This phenomenon by which induced current get produced in the coil due to varying current in itself. The phenomenon, it's not a self-induction. Self-induction is a phenomenon by which, சொல்லுங்க, an induced current induced current slash EMF னு சொல்லலாம். current slash EMF is produced in the coil, is produced in the coil due to varying current in itself. In itself. Suppose நீ switch off பண்ணுறேன்னு வச்சுக்கோ, you are increasing from finite amps to 0 amps. அப்போது நீ switch off பண்ணும்போதும் கரண்ட் எந்த டைரெக்ஷனில் டிக்ரீஸ் ஆகுது, இதே டைரெக்ஷனில் தான் இருக்குது, ஆனால் டிக்ரீஸ் ஆகுது. அதனால you have to enhance it, the induced current will flow in the same direction when you are switching off. Are you clear? When you are switching off, it decreases from finite amps to 0 amps. This is what happens. This phenomenon by which an induced current is produced in itself due to varying current in itself is known as self-induction. 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 So இப்போ வந்து உனக்கு என்ன தெரியும், if E is equal to minus L into di by dt, where L is known as self-inductance. Self-inductance is a proportionality constant. நீ காப்பர் எடுத்துக்கிட்டால் அதுக்கு ஒரு செல்ஃப் இண்டக்டன்ஸ் இருக்கும், வேறு வயர் அலுமினியம் எடுத்துகிட்டு அதுக்கு வேறு செல்ஃப் இண்டக்டன்ஸ். ஸோ செல்ஃப் இண்டக்டன்ஸ் டிஃபைன் பண்ண சொன்னால் E by di by dt with a modulus, நெகட்டிவ் சைனை இக்னோர் பண்ணலாம். செல்ஃப் இண்டக்டன்ஸ் இஸ் a ratio of EMF induced to rate of change of current in itself. Self-inductance is the EMF induced in the coil due to rate of change of current in itself. It's the ratio of E by di by dt. SI unit is 1 Henry. I told you nandri nyavachko, which is 1 volt of EMF induced in the coil due to 1 ampere per second of changing current in itself is known as 1 Henry. 1 Henry is the self-inductance induced in a coil. Self-inductance of a coil when 1 volt of EMF induced due to 1 ampere per second of rate of change of current in itself is known as self-inductance. Are you clear? Henry is the SI unit. Now I'm going to give you an introduction to mutual induction. Mutual induction is a phenomenon by which ஒரு coil varying current இருந்தா, when you go to switch off or switch on 0 to finite amps or finite amps to 0, it will produce an induced current in the adjacent coil. An induced current gets produced in the adjacent coil. So the phenomenon by which an induced current flows in an adjacent coil, the induced current flows in a coil due to the varying current in the adjacent coil is known as mutual induction. என்னோட சோகம் என்ன தாக்கினா செல்ஃப் இண்டக்ஷன், என்னோட சோகம் உன்னை தாக்கினா இட்ஸ் மியூச்சுவல் induction. Are you clear? So அதில் எப்படி எழுதுவேன்னா, flux is proportional to I, flux is proportional to M into I. Putting this in E is equal to minus d phi by dt. It's minus d by dt of mi. So M is a constant, minus M into di by dt is what is EMF. Are you clear? So M is also is nothing but E by di by dt. It's same EMF induced in the adjacent coil due to rate of change of current in the first coil. The ratio of this is known as mutual induction, whose SI unit is 1 Henry again. It's the same. Okay, are you clear? This is only an introduction. Now I'm going to introduce you to something called an inductor. Inductor. What is an inductor? Inductor is a device similar to capacitor. In a capacitor it stores electric field. Inductor stores magnetic field. So inductor is a small device, or spring மாதிரி தான் இருக்கும், குட்டி ஸ்ப்ரிங் மாதிரி. இட்ஸ் எக்ஸாம்பிள் ஆஃப் an inductor is a choke coil. A choke coil is tube lightலலாம் இருக்கும். It stores magnetic field. So inductor is a small device used to store charges in the form of magnetic field. Now let's talk about inductors in series and parallel. Let's take an inductor in series connected to a battery. Okay, you know this is L1, L2, L3. The current flowing in is di by dt, but EMF will be E1, E2 and E3. You all know E is equal to minus L into di by dt. What is getting broken down here is E is equal to E1 plus E2 plus E3, which is minus L into di by dt is equal to minus L1 into di by dt minus L2 into di by dt minus L3 into di by dt. The di by dt throughout will get cancelled, negative sign throughout will get cancelled. L is equal to L1 plus L2 plus L3. It will be like series resistor mariye da you can to do. Supposing it's in parallel, you have an inductor like this. This is L1, this is L2, this is L3. Here the EMF, it's when one moment it's connected in parallel, you know the voltage EMF is a constant. So what is going to differ is di1 by dt, di2 by dt, di3 by dt. Current பிரியும் இல்லை, obviously ஒரு குழாயில் தண்ணி வருது, 3 வீட்டுக்கு பிரியுது. So current is getting split. So what will you do? Right, di by dt is equal to di1 by dt plus di2 by dt plus di3 by dt. E is equal to minus L into di by dt. What is di by dt? E by L. So it's E by L with a negative sign is equal to minus E by L1 because E is a constant minus E by L2 minus E by L3. E throughout get cancel. 1 by L is equal to 1 by L1 plus 1 by L2 plus 1 by L3 அப்படின்னு கிடைக்கும். Are you all clear? So this is just like resistor in parallel மாதிரி தான் behavior இருக்கு. கரெக்டா? ஸோ நெக்ஸ்ட் என்ன சொல்லலாம்? நெக்ஸ்ட் வந்து எனர்ஜி ஸ்டோர்ட் இன் அன் இண்டக்டர். எனர்ஜி அப்படி லெசனே என்ன பண்ணுறேன் அப்படியே ஆஃப் ஹேண்ட் சொல்கிறேன். அது எல்லாம் ஃபஸ்ட் இயரே நான் அப்படி சொன்னேன். உட்காந்து முந்தைய நாள் ப்ரிப்பேர் பண்ணிவிட்டு இதுக்கப்புறம் இது வரும் இதுக்கப்புறம் இது வரும் அப்படின்னு மெமரைஸ் பண்ணிட்டேன். அதுலேருந்து எனக்கு இன்றைக்கி வரைக்கும் மறக்கவே இல்லை. ஆப்வியஸ்லி நீங்களும் உட்காந்து நான் ஃபஸ்ட் இயருக்கு ஏதோ ஒரு டியூஷன் எடுத்துருக்கேன்ல, முடிக்காம தானே எடுத்துருப்பேன். இல்லைனா என்ன ஸ்டூடெண்ட்ஸ் விட்டு போயிருப்பார்ல. அப்போ நான் எடுக்கும்போதே நான் தரவு பண்ணியிருப்பேன்ல. நான் ஃபஸ்ட் இயர் எடுக்கிற மாதிரி காமிச்சுட்டு இருக்க மாட்டேன். ஓகே, பட் ஒன்லி திங் இஸ் நான் ஃபஸ்ட் இயர் எடுக்கிறேன். கமிங் பேக் எனர்ஜி ஆஃப் அன் இண்டக்டர். எனர்ஜி ஆஃப் த கெப்பாசிட்டர் வந்து ½ CV² தெரியும்ல. அப்போ இதில் ½LI² மாறிடும் அப்படின்னு மக்கப் பண்ணிக்கலாம். சிக்கு பதிலாக எல், ஏன்னா கெப்பாசிட்டர் கிடையாது இண்டக்டர். வி வோல்டேஜ்க்கு பதிலாக இல்லை கரண்ட் ½ LI². இது எப்படி வந்தது? வேத மந்த்ரா யூஸ் பண்ணோம். வாட் இஸ் த வேத மந்த்ரா? 10ஆம் கிளாஸில் படிச்சிருக்க. V is equal to W/Q. எனர்ஜினாலே W வரணும். dW is equal to V into dQ. கிராஸ் மல்டிப்ளை பண்ணிக்கும். ஆனால் விங்கிறது இந்த லெசனில் V கிடையாது. EMF into dQ which is minus L into di/dt into dQ. dQ by dt itself is I. So minus L into I into di is dW, integrating both sides. L is anyway a constant of proportionality. 1 dW is W is equal to minus L into I²/2. Considering is the energy, you can ignore the magnitude of the energy is all you want, ½ LI². Thus the inductor energy is ½ LI². That's the very very important derivation. Next, self-inductance of a solenoid. Self-inductance of a solenoid. So ஒரு solenoid எடுத்துக்கோ. Solenoidல you know already it's got n turns and there's a current flowing through. The varying current in the solenoid is going to produce an induced EMF in itself. Okay, you start with E is equal to minus d∅/dt, but you can't write this. Why? You have to include an n because we are talking about a solenoid which got n turns. Minus n into d∅/dt. கொஞ்சம் energy please. Minus n into d/dt of B ds cos 0 ஆயிடும். ஏன்னா the magnetic field is like this and the normal to the area is also like this. Therefore theta is 0. So cos 0 is just 1. Correct? And area is always a constant. So area can be written as A. So now bring it in. E is equal to minus n into d/dt of BA இருக்கு. B of a solenoid நீ மக்கப் பண்ணிக்கணும். லாஸ்ட் லெசனில் வரும் μ0 into small n into I. Where small n stands for number of turns per unit length, you can replace it as capital N by L. Total number of turns by total length will give you small number of turns into I. அதை எடுத்து இங்கே சப்ஸ்டியூட் பண்ணிவிடு. இதுக்கு பிக்கு பதிலாக B of a solenoid என்ன வரும்? minus n into ஏவியும் வெளியே எடுத்துரு. d/dt of பிக்கு பதிலாக சப்ஸ்டியூட் பண்ண μ0 n by L into I. இது பண்ணும்போது இதில் வேரியபிள் என்னன்னு பார்த்தீங்கன்னா I only is changing. கரெக்டாக? சேஞ்சிங் கரண்ட். அதனால் di/dt மட்டும் குரூப் பண்ணிக்கும். குரூப் பண்ணால் என்ன வரும்னா minus μ0 n² A by L into di/dtன்னு கிடைக்கும். minus μ0 n² A by L. μ0, this is like E is equal to minus L into di/dt. செகண்ட் பார்ட் ஆஃப் லெசன் மாதிரி ஆகிடும். ஃபர்ஸ்ட் பார்ட் ஆஃப் லெசனோடது minus n into d∅/dt. அதில் ஆரம்பித்து செகண்ட் பார்ட் ஆஃப் த லெசன் கொண்டு வந்துட்டேன். ஸோ இது அப்படியே பேட்ச் பண்ணிட்டா self-inductance of a solenoid is μ0 n² A by L, μ0 n² A by L, μ0 n² A by L, well capital N² into A by L. Are you clear? இது ரொம்ப ரொம்ப இம்பார்ட்டண்ட். இது next I'm going to talk about mutual induction. Mutual induction தான் நான் சொன்னேன்னா அது phenomenon தான் define பண்ணேன். I'm going to elaborate on mutual inductance between two different solenoids. Okay, you have a solenoid like this which has got, can you concentrate? இப்போ தானே நான் குடிச்ச தொடர்ந்து இங்கே வரீங்களா? இப்படி ஒரு சாலினாய்டு இருக்குது. இப்போ அதுக்கு எதிர்த்தாப்பில் இன்னொரு சாலினாய்டு இருக்குது. மியூச்சுவல் இண்டக்ஷன் ஆன் ஒன் சாலினாய்டு டியூ டு அதர் சாலினாய்டு. இதில் கரண்ட் I1, இதில் நம்பர் ஆஃப் டர்ன்ஸ் N1 A1, இதில் கரண்ட் வந்து I2, நம்பர் ஆஃப் டர்ன்ஸ் வந்து N2, ஏரியா ஆஃப் கிராஸ் செக்ஷன் A2, லென்த் வந்து L2, இது வந்து லென்த் வந்து L1, இப்படிலாம் மார்க் பண்ணிக்கும். டியூ டு த வேரியிங் கரண்ட் இன் த ஃபர்ஸ்ட் காயில் di1/dt, there will be a magnetic field B1 in the second coil. நல்லா புரியுதா? there will be a magnetic field B1 which will induce an EMF E2 on 1. EMF induced in the second coil due to first coil is minus n Faraday's law. n வந்து N2, எந்த coil பாதிக்கப்பட்டதோ அதோட N2 into d∅/dt which is minus N2 into d/dt of B1 dot A2. Because the magnetic field வந்து B1, மற்ற எல்லாமே அந்த செகண்ட் காயிலோட டீட்டெயில்ஸ். Are you clear? B1ங்கிறது என்னது? mu naught into small n1 into I1, where small n1 can be written as capital N1 by L1 into I1. Substituting that in the place of B1, minus N2 into d by dt of mu naught N1 by L1 into I1 into A2. இதில் எது வேரியபிள் கௌஸ்துப்? I1 தான் வேரியபிள். I தானே வேரியிங் கரண்ட் தான் க்ரக்ஸ். ஸோ அதை மாத்திரம் வெளியே எடுத்துரு. ஸோ யூ வில் கெட் அதை மாத்திரம் உள்ளே கொண்டு போய் டி பை டிடின்னு எழுதுரு. மைனஸ் மியூ நாட் N1 N2 A2 by L1 into dI1 by dt is the EMF induced in the second coil due to first coil, which is similar to minus of M21 into dI1 by dt. Therefore, mutual induction on the second coil due to first coil is mu naught N1 N2 A2 by L1. Are you clear? Now I am going to talk about how the first coil is affecting the second coil. The second coil is affecting the first coil. The current in the second coil is dI2 by dt, which is going to induce a magnetic field B2, where because of which the EMF will get induced in the first coil due to second coil. So I have to write E on the first coil due to second coil. E12 is equal to minus பாதிக்கப்பட்ட coilோட number of turns into d phi by dt. Phi is nothing but B dot ds. Bங்கிறது என்ன? Bங்கிறது B2 into A1. Okay, you know B2 is what is affecting it. B2 red color is what is affecting B2 into A1. B2 itself is mu naught into N1 into I1, which is mu naught into capital N1 by L1 into I1. On substituting that here, you get minus N1 into d by dt of mu naught into capital N1 by L1 into I1 into A1. What is a variable is dI1 by dt is a variable, because current only keeps on changing. So then group everything else, minus mu naught N1 N2 A1. ಏನು ಓದಿಗಿದೆ? B2ல N2 சாரி B2னா mu naught N2 I2, N2 by L2 into I2. கவனிங்கடா, N2 L2 I2. So dI2 by dt, கரெக்டா? So mu naught N1 N2 A1 by L2 into dI2 by dt. So E12 is equal to minus M12 into dI2 by dt. Therefore you can see the mutual induction on the first coil due to second coil is mu naught N1 N2 A1 by L2. If supposing A1 is equal to A2 is equal to A and L1 is equal to L2 is equal to L, M12 can be written as M21, because number of turns anyway is there, N1 N2 is getting multiplied. So you can say M12 is equal to M21 is equal to mu naught N1 N2 simply A by L. You can write like this. Now I am going to teach you something which is there is a gap between the two coil, which means some flux leakage can occur. So in order to prevent the flux leakage and induce a maximum EMF, you have to couple one coil over the other. Okay, before which I will tell you, whenever ensoga unna taakudna, ensoga enna indana taakum. Whenever there is mutual induction, there is also self-inductance. So relation between mutual induction and self-induction. Mutual induction, supposing you are multiplying M1 into M2, both this, which is always lesser than L1 into L2. Self-induction enikume adhigama irukum. M is lesser than root of L1 into L2. M is equal to K into root of L1 L2, where K is some factor. Factor means it's 1 by 2, because lesser means K has to be not a whole number irukka mudiyadhu. It has to be a factor. That's a relation between. So how to prevent this is to wind one coil over other coil. The flux leakage can be prevented and a maximum EMF can be induced, provided you have a bigger coil, and inside which you can have the coil of the same size or even a smaller coil. But according to your textbook, they would have given this. They would give you a bigger coil inside which there is a smaller coil. Very, very important. The smaller coil is of the radius R1. The bigger coil is of the radius R2. The smaller coil carries a current of I1. The bigger coil carries a current of I2. You have to, first thing that I am going to, this notes is very important. Okay, so supposing there is a bigger solenoid and inner solenoid, each solenoid, first point, solenoid behaves like a bar magnet. So each solenoid is like single magnet. So supposing I am going to consider outer coil to be in purple color, outer solenoid, the inner solenoid to be in green color, say. So can you see that the green color solenoid, inner solenoid, is in the uniform magnetic field of the outer solenoid, because outer solenoid is a purple color bar magnet. Okay, within the bar magnet you know that the magnetic field is uniform. inside which it's as if the inner solenoid, which is the inner bar magnet, is immersed. So the point that you have to write is the inner solenoid is immersed in the uniform magnetic field of outer solenoid. Therefore, the outer solenoid will have a uniform magnetic field throughout. So the B2 is always a constant which can produce an induced EMF on the first coil due to second coil is minus N1 of the inner coil into d phi by dt, which is minus of the inner coil into B2 into A. Since B2 is a constant, it is easier to find the EMF induced. Correct? Whereas the EMF induced by in the second coil, the outer coil by the inner coil, is very hard. Why? Because the inner magnet will have a non-uniform magnetic field outside, exterior to it. Therefore, the outer coil, main point, outer coil lies in the non-uniform magnetic field of inner coil. So the B1 is non-uniform outside, which is going to affect the outer coil. So the EMF induced in the outer coil due to inner coil is going to be very difficult. Why? Because we cannot substitute the value of B pertaining to the inner coil. You can't substitute B1. B1 is non-uniform across the cross section. It keeps on changing. So then therefore the scientists decided that they are going to consider E12 is equal to E21 and M12 is equal to M21. So you can write the same mutual induction of what affected the, okay, let's write this. Okay, what is this? It's minus N1 into d by dt of what is B2? Is mu naught into N2 into I2, which is mu naught into capital N2 by L2 into I2. Can we substitute here? Mu naught into N2 by L2 into I2, where minus mu naught N1 N2 what else? By L2 into di2 by dt. Something I have left, right? A into di2 by dt, correct? So this is like mutual induction on the first coil due to second coil. Just write it as mutual induction on the second coil, which is mu naught N1 N2 A by L2. Considering both of them have the same length, you can write L1 is equal to L2, but they don't have the same area, right? What is area? What is area here? Area is A1. Area is definitely A1. So you have to write this only for M21 also. M12 and M21 are just the same neutron. You still have only area of the A1, which is the inner coil. Even for the outer coil, you don't seem to be substituting inner coil's area, correct? You only seem to be substituting inner coil's area. This is very, very important. The next part of the last sum, which is very important, you have a smaller circle and two bigger circle, concentric circles. The radius of this is R1, the radius of this is R2, where R2 is much greater than R1. This was a solenoid. So I could write B is equal to mu naught into small n into I, but this is not a solenoid, this is a coil. The magnetic field at the center is mu naught by 2 into I by A. Remember last lesson. So it's like inner solenoid, outer solenoid, inner coil and outer coil. Okay, so due to what is this is a bar magnet, that itself another bar magnet. So inner coil is right in the uniform magnetic field of the outer coil. So the outer coil can affect the inner coil. The EMF induced in the inner coil due to outer coil is minus, number of turns is only 1. So d phi by dt, which is minus d by dt of how the outer coil is affecting the inner coil, which is inner coil's area. Okay, where B itself is this. So d by dt of mu naught by 2 into I by, what is area of the inner coil? A is the radius of the inner coil. What is A? Is R, inner coil is R1. Correct? Into A is, what is this? This capital A is area. No, something, R2. B2 la, you have to substitute this, where it will be R2. Correct? And A1 is pi R1 square. So now what is variable? I only is a variable. So take everything out. What are you going to take out? Mu naught by 2 pi R1 square by R2 into di by dt with a negative sign is E12. The scientist will take E12 to be E21 or M12 to be M21 or mu naught. So then therefore this is like minus of M12 into di by dt. So if this is the mutual induction on the first coil due to second coil, you can write this equal to also M21 for convenience, and they'll write it as the same. Why they can't specifically find out is because the magnetic field of the inner coil is non-uniform to the exterior of it, and that's so you're not able to write B to be one value. Are you guys clear? So this completes the first class that I took.